Welcome, everybody, to today's clinic. I apologize if you were expecting Alexander. We let you down. Yeah, sorry. He's a premium resource, and so you have to settle for second tier or third tier, even worse, when our first tier is not available. Anyway, let's see. Before I sort of maybe talk about a few things that I prepared, are there any questions? Anything HDF related? No? Okay, then I'll jump right in. And yeah, so today's topic is maybe more of an obscure technical detail. Let's talk about versions and versioning, because it's, yeah, sometimes when I remember when I read up on this topic for the first time many years ago, I thought, yeah, backward compatibility makes a lot of sense, but this forward compatibility thing, I'm not sure. And so yeah, just as a reminder, so when we talk about versions and versioning here, we are not talking about you are acquiring data and then you would like to do Git style versioning. You would like to do that type of versioning on your data. That is a legitimate use case and an important use case by all means. And I would point you at there are different ways how you can accomplish that. And number one is we had a previous episode where we talked about versioned HDF5, which is a cool Python package that you can use. Or we had a good presentation at the last HDF user group event about the so-called Onion VFD, which is sort of, as the name suggests, a VFD, a virtual file driver-based solution. And yeah, so if you're interested in that type of versioning, yeah, no offense if you just hang up and say, no, that's not the kind of versioning I'm interested in. And yeah, thanks for coming. So this is about versioning in the context of the HDF5 library and file format. And the first question would be, well, what's the point? Why would you need versioning? And you can look at this from different angles. I would try to put a positive case for that, which is really that there is fundamentally a conflict between innovation and compatibility. There's always new ideas, new features, new things that you want to do. And if you have if you, other than yourself, you have any users, well, that might create a conflict right there. And especially if there's a large community, whatever the software may be that you are creating gathers a sizable community, which we are happy to have with HDF5, then yeah, there is a fundamental conflict between innovation and compatibility, and to sort of mitigate or channel that to some degree, I would suggest that's the why for me behind this. And then, of course, it gets a little more complicated here because we are talking about the library and file format. And I always like this quotation from Jeff Kuhn that is a very it goes back to the early 90s at one of the SGI user group meetings. He had he comes at this from the NetCDF side at the time, and he was talking about, yeah, and he was also comparing the similarities between NetCDF at the time and HDF and so forth. But he said, yeah, at the heart of self-describing data, which is one way of looking at HDF5 in particular, there is this marriage of a format and an access library. And that of course suggests, well, when we talk about versioning here, the evolution both of the library and the file format, while there might be some interdependencies, and then it would be interesting to say, well, where would any kind of coupling or interdependence come from? You, of course, want to preserve a lot of space for this innovation, for the file format to make progress, to evolve, and for the library to make progress and evolve without necessarily introducing a new file format version or library version, whichever it might be. And yeah, it really depends on which library change you are contemplating or which file format change you are contemplating. It may or may not require, so to speak, a reaction on the other side. For example, if you think about at some point we introduced signed metadata in HDF5, I believe it was at 1.8 file format specification version 2, I believe, but I could be wrong. You might say, well, just signing your metadata is a good thing. I'm all for it. But should that trigger a change in the library version? And then if you think about it, well, if you think about it sort of from the perspective of an application, well, what would be the least surprising or the most surprising if all of a sudden the metadata were signed, and superficially you might say, okay, the metadata is signed now, the user doesn't really see it, so why bother? Why introduce a new library version? But then if you think about, well, someone has an application that's linked and depends on an older library version, well, if that were all of a sudden presented with that signed metadata, which wasn't around when that library was created and built and so forth, that's very likely to create all kinds of problems.
Yeah. Gerd, by the way, your the diagram I think you're talking about is mostly off screen. There you go.
Oh, yeah. I'll get to that in a second. Sorry.
Okay.
Yes, thanks. Yeah, so what I would say is two more things before we talk about the diagram. Oftentimes, so if you think about versions, well, how do people typically signify versions? It's typically, yeah, sequences of numbers in some sense. But if you think about a Git tag, for example, that's a version of sorts as well. So I would submit that a version doesn't necessarily have to be a sequence of numbers. But as we will see later, in the case of the library, that's kind of pretty straightforward. However, in the case of the file format, as we will see, it's not that easy. Could you artificially define something that you might call a file format version? I'm not convinced, even if you give yourself all the flexibility and say, well, I'm not going to insist on numbers or something like that. We'll get there in a moment. The other thing is, yeah, so this entanglement, so to speak, between versioning, so why the evolution of the library and the evolution of the file format cannot be completely separate, is that, yeah, there is this concept of compatibility or least surprise or whatever you want to call it. And that's where this sort of cartoon here comes in. And there are all kinds, I can't sort of discuss it here exhaustively, but there are all kinds of scenarios you can think about. So, of course, the first dimension is time, that I consider sort of somehow correlated with any kind of versioning. So you have, call it library A, and A is here a shorthand for some kind of version. I identify them by letters here maybe. And I use library A, for example, to produce an HDF5 file at some point in time. And let's assume that application A is built with library A. Then of course, yeah, it writes that HDF5 file, cool. And then that HDF5 file takes on, if you wish, a life of its own. At that point, it's really, once it's bytes in storage somewhere, it could be accessed by another application. And that other application could be an application that uses another build or another version of the HDF5 library, but it may not use the HDF5 library at all. Again, I point you, there are much earlier examples, but at the latest Hug event, for example, we had a few interesting presentations about Java-based, C#-based, Node-based, and so forth. They're independent implementations that go straight to the bytes in this HDF5 file that don't know anything about the native C library, if you want to call it that, that may have their own ideas about versions and so forth. So how do they come to terms with that container that at some point was generated by library A? And then it continues. You can think about, okay, if you're an applications developer, there is this concept of API, compatible application programming interface compatibility, but then there's also this concept of ABI, not PB, for binary interface. And then, yeah, under what circumstances could you just use a new shared library with your application? You don't have to recompile your application, and everything continues to work just fine. So there are some considerations, but then of course we briefly mentioned already forward and backward compatibility. So what are they? And I listed them here. So backward compatibility means very simply that as the library versioning progresses, that the latest version of the HDF5 library can read all HDF5 files that were ever created by any earlier library version. Very intuitive and very user-friendly, and that's what you would expect from a data management solution that you really want to invest in and have faith in. Forward compatibility is sort of, that's where it gets a little tricky, and you have to read that sentence slowly. So we just talked about library B being able to read the HDF5 file that was created by library A at an earlier point in time, and this is sort of an earlier version. That's backward compatibility. Makes sense. Forward compatibility is, of course, yeah, someone may have an application that's linked against library A, and they are given an HDF5 file by a colleague that was produced a few months later, and it so happens that there was a HDF5 library release, and they built their completely different application, perhaps, or the same, with that newer version of the library, and they create an HDF5 file. And then you could ask, well, if they share this file with their colleague who is still on the earlier version of the library, what are the chances of there being a conflict? So should application A be able to read this without any problems, or what's the potential for trouble here? And that's where forward compatibility comes in. Forward compatibility says it looks as the bytes on disk, what's in the file. And what we sort of guarantee as a forward compatibility is to say, okay, if that later version of the library does not put anything into the file, bytes, primitives, that the earlier version didn't know about or that didn't exist at the time, as long as that constraint is sort of obeyed or satisfied, then the earlier version of the library will have no trouble reading that file. And again, this is sort of this arrow here, this forward compatibility, the ability of the older version of the HDF5 library to read a file that was created by a newer version of the library. However, no feature potentially that was available to this newer version of the library was really placed or embedded or manifested in some form in that file. Makes sense. Okay, so that's forward and backward compatibility, and how the library behaves in practice is sort of this, you might call it the maximum compatibility principle, is that okay, so now how do you configure that we have the H5P default is all over the place. If you look at it at the C level, you might say, well, how do you configure the initial behavior of the library? Should the library always try to be extremely innovative and sort of bring all these latest features to you? And there are good reasons why some people might say, yeah, that's what I want. But then there are equally many, if not more, people who will say, well, no, that's not what I want, because there's all this ecosystem around where this could lead to all kinds of breakage, and I don't want that. And that's why the default behavior of the library is this maximum compatibility principle that says, yeah, the least amount of features that you can get away with to construct, to embed the primitives that you want into the file. And that way you ensure, or you increase the likelihood that, yeah, other tools, other applications in your ecosystem will still be able to read that file and interpret the data. And so far, so good. Okay. Now,
it's slightly complex in the sense, a little bit more complex here, because you can modify any existing HDF5 file with, you know, different versions of the library, so they can get very muddled.
Yes, yes, yes. And this is sort of, again, this is, well, first of all, the artistic qualities are poor, but then also I tried to indicate that, yeah, once an HDF5 file is sort of minted or coined, yeah, it, as Quincy just said, it might take on a life of its own. It gets modified potentially by other versions of the library. It gets potentially modified by libraries in the broader sense that have nothing to do with the HDF5 library, that sort of, yeah, just go straight to the file format specification, and they can do all kinds of things with that file. But then, hey, there's the specification, and as long as you play by the rules, there's nothing wrong with that, or nothing untoward in that. Okay, now so we understand now there is versioning. When we talk about versioning, we talk about the library, but then in a moment, we also need to talk about the file format. So let's talk about the library first, because that's the easy part in a way. Okay, again, looking at it at the C level, but then of course in the Python module, these constants are exposed as well. In the H5Py module, for example, is at compile time in the public header file h5ppublic.h, we expose these version numbers, version major, version minor, version release, and then there is a sort of a string that sort of concatenates all of them in a string form, so that you can use them. For example, if you want to put them into an attribute on a root group or something like that for archival purposes or other purposes. And we talked a little bit about API level compatibility. So we talked about backward compatibility, but then in the library, I mean, there might be new features and so forth, but there will be new API points or functions very likely at some point. And then the question is, well, how do we deal with that? And the good news is the API has these so-called API compatibility macros, and where if you have an existing application and you say, well, this new version that is not API, this new version of the library that is not API compatible, I really want to go there, but I don't want to change my code all over the place. And the good news is you don't have to. You just, at compile time, have to tell the, it would be the preprocessor, to tell the preprocessor to not use the API of the latest version, but stick with the API compatibility level of the version that you build your library with. And that is in practice very good for developers, because yeah, you can incrementally sort of adopt a new API incompatible and maybe also incompatible in some other ways version gradually or incrementally by using these compatibility macros. Secondly, we talked application binary interface compatibility. So we know, for example, that minor updates are fundamentally not ABI compatible. So going back from 1.8 to 1.10, or from 1.10 to 1.12, or 1.12 to 1.14, they are definitely not ABI compatible. Typically there is a ABI compatibility report, definitely on C-, but also as part of our release notes, I believe we distribute an ABI compatibility report that will tell you whether you're going from 1.14.2 to 1.14.3 is ABI compatible, and you can just drop in a new shared object and everything should just work, or whether you have to relink fundamentally. And okay, which brings us to the file format. File format is more complicated. And if there is something that has a version, well, there are two things that definitely have a version. Number one, it's the specification of the file format. And I linked that here. So if you go there, they are here. At this point, there are 4 versions, not counting develop or whatever the current status of this document is, 1.0, 1.1, 2.0, 3.0. And so they have a version. Interestingly enough, also, if you just do a word count, in the version 3.0 of the specification, the term version occurs 566 times. If you compare that with version 1, it occurred only 66 times. So in a moment, we'll think about, well, why is that? There's definitely something that I would call the mighty superblock that has a version. And at this point, it has version 0, 1, 2, 3. And that, if you wish, sets expectations for the file, so to speak. And you do not have, unless you write your own library, you do not have explicit control over the superblock version, because yeah, it's a dancing act between this maximum compatibility principle, but then also your feature use at file creation time, what that superblock ends up being. And then if the file gets manipulated after you closed it, after creation time, that superblock, because of feature use, might get upgraded to a different version. And so all in all, the superblock alone cannot be used as, call it, an HDF5 file version. And it gets in a way worse, because if you dig deeper into the specification, and that's where this 500 comes from, you might say, well, if it's just a superblock, why are there 500 more in version 3? Surely the interpretation doesn't have changed fundamentally. And that's true. But if you read the specification close up, you will see that many of the primitives inside of the file format are versioned, whether it's object.
All of them should be.
Okay.
All of them should be micro-versioned like that.
Yeah. And so that's where the additional versions are coming from. So it's really an HDF5 container, if you wish. It's a living thing, unless you make it read-only and protect it in a way that it's immutable. That's why this term file version is misleading at best. And now, and this is a whole other topic, a much deeper topic, but we don't have time here today. In fact, I'm out of time. But any recommendations? So the good question to ask is, well, what are the recommendations for different people, whether you're a developer or you're a data curator or archivist, or you are a system administrator or HPC center staff? Well, use common sense, number one, but also as a software developer, you should make a deliberate decision about with how much HDF5 or how many HDF5 features, so to speak, you can get away with. And if you are concerned about compatibility, that should be a very deliberate, thought out decision. And you definitely want to enforce that programmatically in your application. I linked here, if you read up on the documentation for H5P set libvirt bounds, that sort of guards the creation of objects, of new objects in the file, and definitely do that as the developer. And yeah, if you at some point have to revisit your original decision, it's always you use the API compatibility macros to make that incremental transition rather than thinking you have to make wholesale code changes throughout your application, which is very laborious, error prone, and might have all kinds of other side effects. Data curators and archivists, definitely you have to mandate some kind of metadata provenance policy and do what Linux distributions do with their LTS flavors. You want to standardize on a long-term support format. Typically, that is tied, whether in NASA's case, it's a satellite mission, it's an instrument's lifetime. There is typically a life cycle in the background somehow that will give you an idea that, I'm committed, or I can time box this decision for the foreseeable future, and this is going to be the level at which I'm operating or we are operating. And then, for system administrator, HPC center staff, people want choice, and people have different requirements. So you are stuck with providing multiple HDF5 versions, but then, you can use modules, containers. There are all kinds of software tools to deal with that. And then I just threw out a few interesting questions. The first question actually came up at the last hub meeting. Somebody said, okay, I'm a developer of one of these independent HDF5 application, and compatibility is not a concern for me. And that's okay, there's nothing to complain about here. What is, if they say, well, I don't really want to support the full file format specification, and I don't want to get into this compatibility game, I just try to keep it lean and mean, so to speak. If for someone like this, is there sort of a subset of primitives of the current specification where we would say, well, to the best of our knowledge and ability, that kind of represents the most modern version, in double quotes, of the file format? And I'm not sure if there is such a thing. Quincy, do you have an opinion on that?
I'm so sorry. What was the question now?
So if someone says, I'm an independent implementer, and so I'm going straight to the file format specification, and I'm not interested in compatibility and so forth, I just want the most modern version of the file format in some sense.
So they're like going to be in a silo somewhere where they never care about reading any other HDF5 files? You might as well do the newer formats. Well, again, it'll depend on your requirements. Do you want raw performance at the expense of longer development time? Because the newer stuff is faster but more complicated. And if you wanted, to get it out the door quickly, then maybe one of the earlier versions that's simpler to implement and somewhat slower and depends on your use case might be a better choice. There's
something
spectrum in there.
We might come back to The second one, probably on many people's minds, is anything what I said so far going to change in version 2.00? Probably not in terms of these compatibility guarantees, and there might be some changes in terms of the defaults, and of course the meaning, at least as far as the library is concerned, as far as versioning is concerned. We are switching to semantic versioning.
So to be clear, though, the semantic versioning only applies to the library version, not to the data format version.
Correct.
Exactly.
Yes.
Okay.
Yeah. But then, next time you have Scott here, you talk to Scott, and then the bigger question is there light at the end of the tunnel? And what I mean by that, yes, I linked a YouTube video here. I think what will make this all much more manageable is automation, broadly speaking. And in this case, what I mean is this idea of a machine readable, machine processable file format specification that can automatically, in your favorite language, create serializers and deserializers. And then I think this tension maybe between innovation and compatibility will be even further relaxed, so to speak. And yeah, maybe you can in a way play with these. I'm not going to call them versions, but sort of you can combine primitives specified in the file format more liberally, perhaps, and to suit your needs than that's possible right now. And there's a very interesting presentations about this Kaitai. We've talked about it briefly in the past, project that Tom Kloiber is doing at the European XFEL. So Tom is at it, and yeah, I hope we can get an update on that fairly soon, or yeah, definitely sometime this year. And that's what I had. Any questions?
So I think it is the case, though, that an older version of the library can walk through an HDF5 file and ingest all the objects that it can identify if an object is something it knows about and read or ingest that one and ignore the others, right?
Possibly.
Possibly. So that isn't something that's...
I mean, if you get a group at the top level that uses some new version of the format that your library doesn't understand, it doesn't matter if all the data sets below it are, readable. So
okay. It gets blocked at that level. Okay. Can you go back to the
Sure.
to your where you have your definition of forward compatibility? I guess
yes.
Yeah, so I was wondering if where the statement read HDF5 files is not a well-defined term. Does it mean exhaustively read? Does it mean partially read? And that's maybe something that
yeah.
So that just kind of struck me when I was seeing that if you can partially read a file, then
yeah. So I think here the emphasis in this sentence is really, there are no features present. So just from looking at the file, you couldn't tell that this was created by a newer version of the file format. So for example, let's take a virtual data set. Well, if there is a virtual data set in there and you are 1.8, well, there were no virtual data sets in 1.8. So a file that contains virtual data sets would not meet this definition.
Right. So your definition really is exhaustively read. That means read every single.
Yeah.
Okay.
I should have made that clear. Yeah. Yes. Yeah. Great question. Thank you. Okay. Well then, unless there are other questions, thank you for coming. And again, apologies if you were hoping to see Alexander here, but he'll be back. And I'm sure he has more exciting things to talk about. Yeah. Although I find this very interesting too. Yeah. Okay. Cool. Thank you. Enjoy the rest of your day.
Thanks,
Thank
Gerd.
you.
Thanks, Ken.
Bye. Mhm.